This is the final video for section 4.3, and this talks about how we can graph the equations that we've just been discussing for straight lines. So, if the equation is given in a nice slope-intercept form, all we have to do is identify the slope, which in this case is -2, and the y-intercept, which is 5. And as long as we make sure to, and I'm going to zoom in here so we can see things a little bit better. As long as we make sure to label our graph that each one of these units is 1, because again, they can be anything. They can be 10, 100, a half. We need to make sure that we label things. And if we do that, then we can plot our points. Our y-intercept, meaning the place that we intersect the y-axis, is at the point 5. And then we have a slope of -2, so we're going to go down 2, right 1, down 2, right 1. And again, we always want to make sure that we have 3 points that we are connecting so that we are actually getting a straight line and we haven't made any errors. Now, it's not always the case that our equation is given in a nice slope-intercept form. So if it's not, then we need to put it in slope-intercept form. In this case, I'm going to subtract the x over, so I'm going to have 6y is equal to -x plus 8, and then I'm going to divide each of these by 6. So we end up with y is equal to -1/6, and it's easier to write the fraction out front and then multiply it by x. And then we have plus, if we reduce that fraction, we have 4/3. Now, if we look at graphing this equation, we need to be careful. We can put things in single units, and it'll be a little bit more difficult to find that y-intercept of 4/3, or we can make each one of these increments a third, because then it's easy to count 4 of them to get 4/3. So again, this is why it's very important that we make sure we label our graph. So if we have our y-intercept of 4/3, we're going to go 1, 2, 3, 4. And since slope is just based on units, not necessarily what the units are on the axis, it just wants to know move 1 unit for every 6 units, we can still just go by these tick marks. We don't have to find what a 6th is here. You can if you want to, but it gets a little bit difficult. So in this case, we want to go down 1 and then to the right 6. And we are only going to be able to fit 1 on this point, so we're going to go the other way with it. We're going to go up 1 and left 6. And then these are going to be connected to get our straight line. Notice in both of these examples we had negative slopes and that these graphs are decreasing. Obviously, example 15 is decreasing at a faster rate because it has a -2, and the next example is at a shallower rate because it is -1/6. So I would like you to pause the video at this point and try example 16. So for example 16, you should have ended up with the following graph. The line should have been y equals 5/2 x plus 2. Be very careful with your signs on these problems. And in this case, we ran out of room on the top there, so I only put 1 point in, and it's kind of an approximation. You can put 2 more lines up here. So then I drew the second point down and to the left. Our final example here, again, we need to solve for y, so I'm going to subtract that 6x over. We're going to get 8y is equal to -6x plus 24. And when I divide by 8, we end up with y being -3/4 if we reduce that fraction times x, plus 24 divided by 8 is 3. And again, we want to make sure that we label our axis. I'll make each one of these 1. You can make them 2. It's really up to you. If we would have done 2 on that last one, it would have fit on the graph a little bit better. Actually, for this one, it will too, so I'm going to change this. I'm going to make each increment 2 so that things fit on the graph a little bit better. And in this case, our y-intercept is 3, so we would go 2 and then halfway up to get 3. And our slope is -3/4, so I'm going to go down 1, 2, 3, and to the right 4. And this is where we have to be careful, because again, this is really 4 here. Likewise, if we go another down 3, 1, 2, 3, and to the right 4 units, we get this point here. So we have another negative slope leading to another declining or decreasing function. This concludes the video for section 4.3. Please go online now and complete the homework assignment for this section.